Good afternoon, everyone.
Good
How was
afternoon,
your
sir.
day? How was your day, Ryan?
Stress.
Stress. Judy.
Same, sir.
How about Marvin?
Kapoy sir, gikan ako nagbike.
Very good. At least it's exercise. Okay. The last two meetings we talked about what was our topic again? For the first meeting, official meeting of our discussion, we talked about embedded systems. On the second one, overview of robotics as well as the artificial intelligence. Okay, and if you've missed out those lessons, I will give you the PDF file of my presentation after we finish the topic for simple machines. Okay, so for now, let's talk about simple machines. If you're already familiar with it, then I think the most common one is the pulley system, which will be tackled later on. So let's proceed. Work is the application of a force to an object to move it a certain distance in the direction of the force. So that is work. When there is a force, then you move it at a specific distance, then it is work. The formula for work is W, or work, is equal to force times distance, or W is equals to F times D. So you have to remember this formula. So force is a push or a pull. So your act should be a push or a pull by opening the door. That's already a force because you apply push or pull, right? And a force is measured in newtons. If you're familiar with newtons, we have it in our physics subject. That's how you measure a force. Now, the distance is the amount that an object travels. Of course, it's usually measured in meters. For the Philippines or for the metric system, it's meter. Now, in our country in the US, usually we use miles. That's why we have like 20, 30 kilometers per mile, 30 miles per hour. Those are the measurements. Now, in our country, since we're following the metric system, then it's meter. So, force Newton times the distance traveled, that's the work that you have done. Now, work is done only when an object moves in the same direction of the force that is being applied to. Okay, like for example, when you push an object, then it's moving to the direction where you pushed it, not the opposite direction. Right? May siguro gitok yun na pabalik. Okay? Now, movement equals to new work then. Example, picture a person. Picture a person wearing a backpack and climbing up the side of a mountain. The person is doing work because the direction of motion and force being applied are both upward, same direction. So there is work there from the force, the effort for climbing, and the direction or the distance traveled by the person. Okay? Now, work is not always done when a force is applied to an object. So there's always like an exemption because work is not always done as said in this statement when a force is applied to an object. What is the example? Now the example is a brick wall will not move no matter how much force you apply with your hands. So like for example, if you're now beside your wall, just try to push your wall. If it will move, then if it moves, then you're Superman. If not, you're a normal person. Okay? The wall does not move, so no work is being done when you push on it. So there's no work because again, you apply the force, but there is no distance traveled from pushing it. So that's like for example, the force is 20 newtons, and then the distance traveled 0, that's still 0. Work is equal to 0 because when you multiply a number by 0, the result is still 0. So no work applied. Now, let's go to the main topic, which is the simple machines. So, are you familiar with simple machines already? So, we have talked this like for our high school days, elementary days. Now, there are 6 basic types for simple machines. They are designed to make work easier by changing the size or direction of a force. Have some moving parts, can combine to form a compound machine. So these simple machines, as you can see on the figure on the right, can you see it, guys? Can you confirm that you can see the image?
Yes, sir.
Klaro, sir.
Okay. Now, if you form like a combination of lever and wedge, then that's compound machine. But for a simple machine, their application is specific also. Like for example, we have here the 6 simple machines. Just try to remember this because if we'll have tests or exams or quizzes, of course this will come out. Like for the lever, you know what lever is? Not the one in our body, but of course the lever. Lever. It's we have here the object, the fulcrum, and the force. Okay? Like for example, are you familiar with the bara that we use when you're constructing or like uh, pico in farming? We have, I think it's called pico. When you try to plow the land and then use pico because that's the easiest form when plowing the land, right? So that's example of a lever. So the next one we have inclined plane. You just have to follow the image. We have here you apply the force. Like for the lever, you can see the arrow. The force is downward. This is the object here. This is like let's say that this is the load for the lever. When you push this one, can you see my arrow, my mouse arrow?
Klaro, sir.
Okay. When you push this lever here, of course, this object will go up because you applied force here. Okay? And in lever, there is a fulcrum to make a stability when applying the lever. And on the other side, we can see here the inclined plane. This is commonly is when you actually like work on the grocery stores, like for example in Palma. So their workers they use also inclined plane to push or to move objects from one place to another. So we have here the force. When you apply the force here by using this inclined plane, it will make your job much easier than lifting here because when you lift this object from the ground until here, so that's the work that you have to do is much compared to the one using inclined plane because it's much easier. Now we have the third one, the wheel and axle. So wheel and axle, we have here the force when you turn it, and the force from turning this one will make this wheel here turn. Okay. So of course, like for example, how do we explain this? If you have seen the pole used in badminton or volleyball, so you apply force here to transfer it from one place to another. So that's one effective way of wheel and axle. And then we have wedge here. Okay, when you the wedge focuses on like when you apply the force, usually wedge has like a sharp edges here. So when you applied force, you cut something out from it, like a scissor. A scissor is a compound machine. It's a combination of a lever and a wedge. Okay. So the wedge is the cutter itself. So it makes the job easier in cutting the papers. And the lever is the one that you push like to cut the papers. You hold it and then the wedge actually cuts the paper itself. Now the
Ang
most
lever
common one,
kibali sir ang handle.
ah,
Ang handle kibali sa
oh, a
walking away
handle.
lever.
Yes, of
Yes.
course. The lever is the handle. If I'm not mistaken, you can verify the things that I'm saying right now. The common one is the pulley. If you're familiar with this, like flag when you do flag racing, that's a pulley system. Okay, when you pull the string and then an object will rise up. Like for example, when you pull the string, the flag rise up to the flag pole, and then that's one example of pulley system. Mostly, pulley system is used in construction. Like they don't have advanced machines in construction. Like for the mason and the carpenters, they use this one because on the second floor they cannot just carry the cement on the second floor manually. So they use pulley system just to grab the end of the rope and then transfer it to the second floor. So that's one basic application of the pulley system. Now screw. Screw is one of the most efficient because we use this to tighten up our objects. Our laptops has screws on it to make it fixed and not movable and not just easily damaged because if you just use like adhesives, then you're not sure that it will last long. That's why our mostly of our consumer electronics product has screws to make it fixed and not movable, as I've said earlier. Now that's for the simple machines. Again, lever, inclined plane, wheel and axle, wedge, pulley, and screw. So those are the six basic types of simple machines. Now, an inclined plane is a straight slanted surface. We have discussed it a while ago, right? So an inclined plane is a straight slanted surface from the word straight but slanted surface. So this is a straight one. The only difference is that it's slanted. Okay? For example, a ramp is a stationary inclined plane. You have this one to stop the to make it stable here, and then the inclined plane and the object for pushed towards the center of this object also. It is easier to push an object up a ramp than it is to lift the same object straight up to the same direction. Because when you do this slanted object, it's much easier, as I've said earlier. Because when you lift an object, this one from here, then it's a different force that you apply. So that's more force compared using inclined plane. Now wedge. A wedge is an inclined plane that is wider and thicker at one end than the other. We have here thicker and wider side of the wedge. Example, knife, blade, or axe. Okay? So there is, as I've said earlier, there is like a sharp edge of those wedges because like for example knife blade, so knife is a sharp object, so it from the song life cuts like a knife, so you cut anything like from paper, from fruits, from the food that you eat, so you need a knife to cut it or the axe. So no one uses axe here to cut fishes right? So mostly we use knife, but for the things that are not as easy to cut, we use axe. Like for the wood, for other things that require much force, so we use axe. When moved, it is used to cut, split, or pry apart objects. So the main use of wedge as a simple machine is to cut. Oh wait. is to cut, remember ha, to cut, split, or pry apart objects. Now screw. A screw is an inclined plane that is wrapped around a cylinder. So for example, even the bottle cap is a type of screw as example because when you turn it, you can open like soft drinks, like tanduay, Coke, Black Label. Those are example because they have cap that you can just easily open because it has a screw feature. When turned, a small force is applied over a long distance of the screw's threads. As you can see here, these are the threads of the screw. The longer, like the manyer the number of these threads, the longer you apply the force. Okay, so can you you just have to imagine it. If this is just like 1, 2, 3, 4, 5 threads, then it's easy to unscrew it because it's fewer in terms of threads. The amount of work for a screw depends on the number of thread, which is actually the length of the inclined plane. Okay? When basically when you use the screw, you connect two inclined planes as explained. So that's the reason is to connect those two inclined planes to make it sturdy and stable. Okay, still up? Still
Yes,
there?
sir.
Yes, sir.
Okay. Nice, nice. Now let's
Baso,
proceed.
baso.
Basu, basu. Later, later. Next, a lever. What is it? Made up of a bar that pivots at a fixed point called a fulcrum. So the fixed point is called the fulcrum. The force applied to a lever is called the effort. So when you do force with the lever, then that is the what you call it is the for effort that you use. The object moved is the load. So I've said it earlier, the object, the one that I've showed you is actually the load. So object is equal to load. They are classified into three different groups. The groups are based upon the locations of the fulcrum. We have the load, fulcrum load, and the input force. Okay. There we have example here. In a first class lever, the fulcrum is in the middle load and force on the ends. Can you see this one? So this is the first class lever. So seesaw shovel. If you're familiar with seesaw, we have here at Luneta Park. So the fulcrum is in the middle. Okay? Like let's just imagine that this is Ryan. Ryan is the load and Marvin is the force. So when Marvin exerts force here downwards, so Ryan will go up. On the other hand, if Ryan, the load, applies force downward, then Mark will rise as well. But if you both apply force, then you're in the middle. It depends on the force applied on the lever. So again, the example are seesaws. So for the second class lever, the load, the resistance is in the middle. The force and fulcrum are on the ends. Example, nutcracker, wheelbarrow. If you have used wheelbarrow, the one that you put your soil and the one that you load some objects or loads there. So for the second class lever, we have wheelbarrow and nutcracker. So again, the fulcrum is on the ends and the force. The load is in the middle, as you can see here. So force is always applied here. Well, like going up, okay? Let's just imagine when you lift a wheelbarrow, when you lift it, then there is load there. Then the load will move down because you applied force upwards. Okay, of course, when you lift an object upwards, this is the wheelbarrow, then all the soil, like for example, of course, will slide down. So that's the second class lever. For the third class, the effort is in the middle. The load and fulcrum are on the edge. Example, baseball bat or fishing rod. Okay. Now the fulcrum is here, the force is here, and the load is here. So like let's just fishing rod. You put this one on your belt, right? Let's just imagine this is a fishing rod, ha. So mostly fishing rod, the end part is located on the belt side. Now the load here, let's say this is the fish, or like it's a shark. So when you fish, you again when you use fishing rod, the force that you exerted is in the middle, right? So if lang pa, if naanay subad, and then you pull it, you exert effort on the middle part, so the load, and then until you get the fish. So that's the third class lever. Okay, still there? Now let's proceed with the pulleys. Not the police, the pulley system. A pulley is a rope or chain wrapped around a wheel. So there are two things in a pulley that we can use: the rope one and the chain. So usually it's the rope, but for mega structures they're already using chain. So basically a rope is wrapped around this wheel here. Okay? You can also use chain here, cadena, to lift an object. So as you can see here, a load is attached to one end of the rope. So this is the load or the object. A force is applied to other end of the rope. So as you can see, we have arrows here to indicate the force. So the force is downward. If we apply force here, then the object will rise up. So that's basically the pulley system. So it's very understandable. A double pulley makes work easier not only by changing the direction of the force, but also by multiplying the effort. A single pulley makes work easier by changing the direction of the effort force. When you pull down on the rope, the load moves up. So this is the single pulley system. But if you have double pulley, so apply force here, the force will go up and the load is here. And then, so as you can see here, there are two wheels and the rope is connected to the two wheels. As explained here, double pulley makes work easier. So basically, you just have to understand that pulley system when lifting object from higher grounds is much easier to do because we have already the wheel that makes the effort here plus the force you apply to the rope or the chain. So that's the pulley system. Now let's move on to the wheel and axle. A wheel and axle is a simple machine that consists of two circular objects of different sizes. The wheel is always larger than the axle. Okay. So we have an example here, the doorknob. If you have doorknob at your house, so that's one example of a wheel and axle by getting more force from the effort put in when compared to the amount or distance. So if you just have to imagine your doorknob in your house, you exert effort by turning the wheel, which is the handle. Okay, then as you cannot see what's inside it, or that's behind the door. So basically that's where the action happens. Okay, am I still clear? Am I audible still? Can you still hear me?
Yes,
Yes,
sir.
sir.
Okay. So now let's review, ha. Again, guys, simple machines. Let's just have a recap. We have the lever, we have the inclined plane, wheel and axle, wedge, pulley,
Pulley and
and
screw.
screw. Okay, you just have to remember those things. Now, let's make an example. Eduardo is helping his family move out of their old house. Help him decide which task would be easier and then help him figure out what simple machine makes the job easier. So, saan daw? Para mas simple ang ija life. Like for me, lazy, usually kung puluho kita, we make sure that when we're lazy, we find ways to make our job easier. Okay? Now, Eduardo has to move some heavy boxes into the moving truck. Would be easier because ramp is an inclined plane. Like for example, so if can you see this image here on the left side compared to the right side?
Yes, sir.
So on
Yes,
this
sir.
on the left side, Eduardo has to move boxes to the truck. Okay, so he needs to lift it up. So that's more effort compared to the image as you can see on the right side. He uses inclined plane, but I don't know why Eduardo can push this one or just use this stable platform here compared when he still has to lift this one. But I think the figure can explain better if Eduardo has just pushed the box here towards the truck. Okay, so that's one application and that's one solution to Eduardo's problem of moving some heavy boxes into the truck. So Eduardo uses inclined plane. Now Eduardo has to move a heavy box along a distance. Would be easier because the wagon has wheels and axles. Like for example, if you just leave this one, that's more effort. But if you use wheels and axles, as you can see here, just put your load here and then you pull the wheel and axis as referred to this figure here. So your job was easier already. Okay. What's the example? Push carts. I think push carts is a good example. So you don't have to lift your loads, but you just have to put it inside. So you just have to push or pull your objects so for you to not exert more effort. Eduardo needs to tear off a piece of packing tape. Would be easier because the edges of the scissors are wedges. So, when Eduardo needs packing tape done, so what is the machine that we usually use? So of course it's the scissor, right? So this is very explainable because scissors usually cuts. So Eduardo used the scissor because that's one example, as I've said earlier, of a wedge. It has a sharp end, of course. Now, Eduardo needs to move a heavy box to his room on the fourth floor. Okay. This is A and this is B. So for A, Eduardo needs to travel the box from like first floor, second floor, third, and to the third floor. Lang. One, two, three. Fourth floor. So if imagine Ryan, you're this Eduardo and you need to lift this box or load into the fourth floor. So that's some heck of a force you need to apply. When you reach the fourth floor, then you're already exhausted. But as you can see on figure B, it would figure B would be easier. This one, figure B, would be easier because Eduardo is using a pulley. Okay? So Eduardo does not need to climb to the third floor using the stairs, but instead he uses the pulley system. Okay, you got it? So that's one application. Now, Eduardo needs to help his father move the refrigerator. So, what do you think is much better, letter A or letter B?
Letter
Ah,
A.
of course, it's letter A. Letter A would be easier because the dolly is a lever with wheels and axle. So this one, as you can hear from handle here until here, it represents a lever. So the force is here, applied here, and then with wheels and axle. So this is the wheels and axle here. So it rotates. So it's much easier than compared to figure B. How can you even transport this without the help of like three person or four person? So by
Si Hook
using
ko na nag-alsa, sir.
ha si Hook.
Si Hook ang mag-alsa.
Pwede ra tabangan ni Jack Marvin sa ni Ryan. Si Judy ray mag-instruct ha idapit. Now, so mas easier si Jack. Eduardo needs to help his father change a flat tire on a moving truck. A, B. B would be easier. This is figure A and this is B. B would be easier because Jack uses a screw. Okay? So how can Jack lift this without the what's example of this in the automobile? I think these are all approaches already because we have a jackhammer. Jackhammer is I think it's hydraulic, so it uses to help lift the car. So there are still things like this which are in screw feature. You just have to turn it to lift the vehicle. So that's
Ang
what
dagko ang mga bago ko man ng mga jack, sir, kay clever naman dyan matawag kay mura ka
Oo.
bomba-bomba raman kan. Di na dyan
Yes.
matawag na
Oo.
screw.
Oo, hangin naman dun sa suyod. Ilang na dyan i-pump out para mo makalift siya. So, but it's still, this is the figure B would be much easier. Now that Eduardo and his family have reached their new house, they need some help in unpacking their belongings. Help Eduardo decide on the best simple machine to use in this situation. Okay. Eduardo needs to open the boxes his mom sealed with packing tape. What simple machine should he use? Very obvious. We use scissor, which is an example of a wedge. Now,
Wedge.
the door to the moving truck is jammed shut. What is the simple machine might Eduardo's father use to open it? So, sa ato, we call this as bara, right? So, since it's jammed, Eduardo father should use a lever, most likely a crowbar. The English term is crowbar. So, again, that damages the door. Okay? Eduardo needs to carry the boxes out of the moving truck. What simple machine will make this easier? Eduardo needs an inclined plane, okay? A ramp to carry the boxes out of the truck, okay? Eduardo can push the box here towards the ground or from ground to the vehicle. There is a flagpole outside Eduardo's new school. What simple machine could be used to raise and lower the flag? Of course, I've explained earlier, a pulley is used to raise and lower the flag. So we have here the pulley. Just imagine that this is the flag of the Philippines. So just imagine this is Marvin. Marvin is tasked to lift the Philippine flag for the flag raising ceremony. And Judy was the one beating the lupang hinirang. Bayang mag Okay, next. Eduardo's mom wants to hang a cabinet in the new kitchen. What simple machine might she use to attach it to the wall? Eduardo's mom could use a screw to attach the cabinet to the wall and hold it in place. So if your wall is wood, then it's easier to attach the screws. But if your wall is concrete, then you use um barina na sa ato doon, di ba? Tawag. So we use those things to make our screw much easier to attach. Okay, so one example here is the screw. The next one, Eduardo helped his father install doorknobs in the new house. What kind of simple machine is a doorknob? A doorknob is a wheel and axle. So during the exam, if we ask what example of a wheel and axle is, then you can answer a doorknob. So that's an example. Just have to remember it. Okay. So you have already got the idea of the different simple machines, and I've um talked about a lot of example, even the situation or scenarios for you to get the right information about the simple machines. Of course, and in simple machines, there is also like an effort. Usually, if we dig down to the details, then we compute for specific force applied to the distance covered, the mechanical advantage of our simple machines. There are things that you need to take note for you to be remembered to remember about the simple machines topic that we have right now. Computations, energy again is ability to do work. Okay, work is force times distance. Again, W is equal to F, force, times D, distance. That uses a push or a pull for you to have a force applied on a certain object. Now, work input and output. Work input is the amount of work done on a machine. Okay? You just need to remember this. Work input is the amount of work done on a machine. So, input force times input distance. So generally, the formula for work is force times distance, right? You still remember that, Judy? Work is equals to force times distance, right?
Yes, sir.
Okay. Now, since it's input, a work input, you just have to add input and input here. So work input, of course, is equal to input force times input distance. Now let's talk about work output. It's the same thing. Work output is the amount of work done by a machine. So work output is equal to output force times output distance. Okay? So this figure is an example of it. Tayo na ba natin if we see this thing, it confuses us. Work out is equals to work input. Force out times distance out. So that's output force times output distance is equal to input force times input distance. Okay? We have this on this figure, if you refer to this figure, we have this 10N. So what this 10N is all about? So it's 10 newtons. So N represents newtons. Okay? So output, as you can see here, this is like the example of this is an inclined plane. Okay? So, for example, for the output force and output distance, we have an example here. We have 10 newtons times 3 meters is equal to 2 newtons times 15 meters. Okay pa mo? Nice. Do you have questions so far? Ryan, Marvin, and Judy, do you have questions so far?
Yeah, pa sir.
Okay. Marvin, you have questions?
No, sir. None so far.
Judy?
No, sir.
Okay, let's proceed. Let's talk about the mechanical advantage. So let's just talk about the mechanical advantage of the different simple machines. So you will have an idea about it. Now, the mechanical advantage of an inclined plane is equal to the length of the slope divided by the height of the inclined plane. So again, its mechanical advantage is equal to the length of the slope divided by the height of the inclined plane. So again, it represents MA or mechanical advantage is equals to length of the slope divided by length of height of the inclined plane. Okay. So MA mechanical advantage is equal to 15 feet, which is the slope here. Slope is the other term that you could use is the slant or slanting. So 15 feet divided by 3 as the height. So the mechanical advantage is 5 feet. Okay. Screw. The mechanical advantage of a screw can be calculated by dividing the circumference of the pitch of the screw. So pitch equals 1 and number of turns per inch. Okay? So as you can see on the figure here, one of those that we can easily identify is a drill bit. If we have drills in our house, the longer the drill is, the longer it will penetrate, of course. Dependent on what type of materials, especially the metal used for the drill bit. For the screws, we have the threads here. One of the things that you can consider that it would help you much better if actually the threads are near to each other. So you don't need to exert force in turning the screw because the number of threads are calculated properly. Okay. Now for the wedge, the mechanical advantage of a wedge can be found by dividing the length of either slope S and by the thickness of the big end. Let's just imagine that this is the end of the scissor. So the mechanical advantage is the is found by dividing the length. So this is the length of either the slope. S is represented by slope. This is the slope. Slope kay slanting siya. And the thickness of the big end. So this is the big end. So you just have to divide what, like for example, this is 10 and this is 5. So 10 divided by is equal to 2. So that's the mechanical advantage of a wedge. So basically, when we apply it to our scissor, the longer the scissor, the faster that we can cut the paper. So we use less force and we put a faster approach to it. An example that assume that the length of the slope, like that we have an example here, is 10 inches and the thickness is 4 inches here. The mechanical advantage is equal to this here 10 divided by 4 here, or that's 2 and 1/2 in fraction. As with the inclined plane, the mechanical advantage gained by using a wedge requires a corresponding increase in distance. We have talked about this earlier, so we have again the first class lever. The mechanical advantage of a lever is the ratio of the length of a lever on the applied force side of the fulcrum to the length of the lever on a resistance force side of the fulcrum. If you can still imagine or if you can still remember, when using a seesaw, it would much be easier if the fulcrum is in the middle, right? Because the force exerted is not as much compared when the fulcrum is on the end of the seesaw. Okay? So that's one example of how you just have to try to imagine that one. Like for example, we have here Ryan. This is like for Ryan, and then this is Judy. So Judy has an advantage over Ryan because on this side it would be much easier. Okay. Again, we have the second class lever. The fulcrum is on the end. Third class lever. Fulcrum is on the end as well. So we have also like examples of fixed pulley here. Fixed pulley changes direction of force. However, it does not create a mechanical advantage. The mechanical advantage of a movable pulley is equal to the number of ropes that support the movable pulley. Okay. So this is again the combined pulley system. Wheel and axle is stuck rigidly to a large wheel. Fan blades are attached to the wheel. When the axle turns, the fan blade turns. So this is an example of a wheel and axle. So we have a fan and it will turn, 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 turn because of the wheel. The mechanical advantage of a wheel and axle is the ratio of the radius of the wheel to the radius of the axle. In the wheel and axle illustrated above, so as you can see, we have the figures number 1, 5. The radius of the wheel is 5 times larger than the radius of the axle. Therefore, the mechanical advantage is 5:1 or 5. The wheel and axle can also increase speed by applying the input force to the axle rather than a wheel. This increase a computed like mechanical advantage. This combination would increase the speed 5 times. Since the ratio is 5:1, then it would also mean that the speed will increase 5 times. Each gear in our series, for we have in wheel axis, we also have gears. Each gear in a series reverses the direction of the rotation of the previous gear. The smaller gear will always turn faster than the larger gear. Okay, because it the distance of the teeth here on the bigger gears are wide enough compared to the one for the smaller gear. Okay, that ends our discussion for the simple machines. Do you have questions?
Yeah, sir.